All right, so in the first two examples, we walked through solving these trigonometric equations algebraically, and they were pretty straightforward because the constant value that we solved for was pretty visible on the unit circle. Now, the work that we're going to be doing here is a little bit different because the value square root of 3 over 3 is not one of the x and y coordinates. And also here, we don't have just theta, it's offset by pi over 6. So what we first should probably define is the trig ratio here. So we know the tangent of theta is going to be equal to the sine over the cosine of theta, and we know that sine is y, the y coordinate over the x coordinate. Now if we're thinking about cotangent of theta, it's going to be the inverse. It's going to be equal to the cosine of theta over the sine of theta, and that's going to be equal to the x over y. So there's some things we can identify here about this constant value. We see that this constant value is positive, so that tells us we're going to be establishing a ratio of two coordinates that are either going to be both positive or both negative, because we know that the quotient of two positive numbers is positive, and we know the quotient of two negative numbers is also negative. So one thing we want to think about here is the relationship between fractions and when you do your division. So what I'm going to do here is I'm going to just look at all of the values here that have a positive x and a positive y, or a negative x and a negative y that include that radical 3. That'll be how I'm going to isolate sort of my approach here. So I know that I need to have a ratio of x to y, and since my radical 3 is in the numerator, I'm going to make a guess where I'm going to look at this coordinate pair right here, so pi over 3, and I'm going to look at this right here, 4 pi over 3. So what we can do is we can set up those ratio, and we'll look at pi over 3 as the first one. So it's going to be 1/2 divided by the square root of 3 over 2. Now the rule when you're dividing fractions is you can keep the numerator the same, change the operation to multiplication, and then you can multiply by the reciprocal of the fraction in the denominator. So the reciprocal of square root of 3 over 2 is 2 over the square root of 3. We see that there's a factor of 2 in both the numerator and the denominator. So this simplifies into 1 over the square root of 3. Now we're close to where we need to be. However, we're not exactly there yet. So you may or may not recall the process of rationalizing the denominator. So essentially what we want to do here is we want to get that radical sign out of the denominator. And we do that by applying this rule right here, where you multiply a root by itself. That ends up becoming the square root of 9, or just 3. And then we have 1 times the square root of 3, which is just the square root of 3. So essentially what we were able to do there is we were able to verify that the ratio of 1/2 to square root of 3 over 2 does yield a quotient of the square root of 3 over 3. So pi over 3 is in fact our one of our solutions. However, we know that this right here, theta plus pi over 6, must be equal to pi over 3. Okay. Now this theta value is offset by that pi over 6, so we need to account for that in the work that we're doing as we're defining the solution. So in order to solve for theta, we subtract that pi over 6. Now we can't subtract these just yet because we need the same denominator. So if we multiply pi over 3 by 2 over 2, it gives us 2 pi over 6 minus pi over 6, which yields a difference of pi over 6. So while we know that the ratio of the square root of 3 over 3 is connected to this pi over 3, we needed to offset that input value to account for the plus pi over 6 in this given scenario. So now what we're going to do is we're going to jump into the other solution that we we identified the 4 pi over 3. And since the x and y coordinates are the same as the original test value, except for the fact that they're both negative, we know that the result is going to be the same. So we know that 4 pi over 3 is a solution. However, we need to, let's clean this up a little bit. So we have 4 pi over 3 is equal to theta plus pi over 6. So we need to do the same thing here where we are going to subtract pi over 6 from both sides of the equal sign. So in order to do that, we're going to quick convert this to 8 pi over 6. 8 pi over 6. And then if we subtract pi over 6, we're left with our theta value here. And then 8 pi minus pi just gives us 7 pi over 6. And that's equal to our new theta value. And that's less than 2 pi, so we know that this one will also satisfy the restrictions on this particular interval right here. So just to recap a little bit for this problem, it's a little bit more nuanced because the constant value that we set the trig function equal to wasn't a clear match to the unit circle. But as you continue to do this work, you'll find that the same patterns will start replicating themselves based on sort of the ratio of the x and y coordinates, especially when you're working with tangent and cotangent functions. So if this was a little bit confusing, go back and watch it again. If you have follow-up questions or need clarification, please let me know. That feedback will help me refine these videos to make them better as we move forward. Anyway, again, hopefully this was helpful. I definitely look forward to listening to your feedback.